Which is better, object-oriented or functional programming? How about composition or inheritance? Semicolons or no semicolons? Is it pronounced GIF or GIF? And is a hot dog a sandwich? Today you'll get all of the answers, and I encourage you to just accept these as the facts and not try out anything on your own. There's only one correct way to write code, and if there's one thing that employers hate, it's creative problem-solving skills from their programmers. If you're new here, like and subscribe, and congrats to Alexander Torres, you're the random t-shirt winner from last week. And a huge thank you to Patrick Milou. He contributed to the content of this video and has helped out hundreds if not thousands of developers on our Slack channel, so make sure to spam him with a thank you message. Let's go ahead and take care of the easy ones first. When writing your code, you should leave semicolons out, and then have Prettier add them back when you save the file. GIF stands for Graphics Interchange Format, so it's obviously pronounced GIF, following the first word in the acronym itself. Is a hot dog a sandwich? Well, that one's a little more complex, so let's wait till the end of the video. How about object-oriented versus functional programming? If you guessed object-oriented is better, you're completely wrong. And if you guessed functional programming, you're way off base. Debating programming paradigms at this level is like debating art. There is always more than one way to solve a problem, especially in JavaScript, and it's great to debate these things, but there are no absolutes. There's going to be a trade-off for every decision that you make. Let's start by taking a look at some functional TypeScript code. The most important concept in functional programming is the concept of pure functions. This means that the output of your function should only depend on its inputs. For example, here we have a function called toString, which takes a value as its argument, and then returns that value formatted as a string. We can make this an impure function by mutating the number variable directly. This would be considered a side effect, and functional code should produce no side effects. In addition, they should not rely on any outside value to produce a return value. Pure functions are easier to test and also easier to reason about because you don't have to think about anything happening outside of the function itself. Another core principle of functional programming is immutable data. Functional code is stateless, meaning that when data is created, it is never mutated. For example, we can simulate this in JavaScript by using object freeze on this array of numbers. We could hack around this, but it prevents us from doing things like array push, which you wouldn't do in a functional program. So obviously our data has to change somehow if we have a dynamic software application, so you'll often be passing functions as arguments to other functions. So here we have a typical first-order function which takes a value and returns a different value. In this case, just appending an emoji to a string. Now, a higher-order function is one that either takes a function as an argument or returns a function itself. JavaScript has some really nice built-in higher-order functions for arrays, such as map. So instead of using a for loop, we can just pass in our function toMap, which will run our addEmoji function on every element in the array and transform the value. So that gives us a very concise and elegant way to transform the values in an array. Another cool thing we can do is create functions that return functions. This is very useful when you want to start with some base functionality and then extend it with some dynamic data. Let's imagine we're building a weather app and we need to append strings with certain emojis. We'll start with a base function called appendEmoji and then use it to compose more complex functions. So in this case, the inner function takes both of the arguments and adds them together. We can use this to create more specialized functions that point to a specific emoji. For example, we'll have a rain function and a sun function. Then we can call this function with the string that we want the emoji appended to. The end result is some concise and readable code that doesn't rely on any shared state that would make it difficult to test. That's about as basic as it gets for functional programming, and things get a lot more interesting when you have asynchronous data and side effects and things like that. So now let's go ahead and compare this to object-oriented programming. The best comparison I've seen is to a baking recipe. I'll have a link to that in the description. The object-oriented or imperative approach on the top gives you a clear set of statements to follow to get the cake to its final state. The functional or declarative approach on the bottom describes the state and logic involved, but has no opinion on the actual control flow. Now let's go ahead and look at some object-oriented TypeScript code. The first thing we'll do is define a class, which itself doesn't really do anything, but rather it serves as a blueprint for instantiating objects. So an instance of this emoji class will be an object with an icon property. Then the constructor method is special because it runs once when the object is instantiated. We'll pass an argument to the constructor with the actual emoji icon, and then we'll set that equal to the property on this object. And the emoji class works similar to a function, but we use the new keyword in front of it. And as you can see when we do that, it creates an emoji object with an icon property of sun. In TypeScript, there's an easier way to do this because we have the concept of public and private members. So if we use the public keyword in front of the argument in the constructor, TypeScript will automatically know to set that as a public property on each object. When you declare a property or method public, it means it's available to the class itself and any instances of the class. That can be both a good and a bad thing. For example, we can simply change the icon by just mutating the value on this object. On one hand, it's very convenient, but on the other hand, if you have a lot of code doing this, it can be hard to keep track of and hard to test effectively. I'd like to point out at this point that classes in JavaScript are actually just syntactic sugar for functions and prototypal inheritance. If we compile our code to ES3, you can see that it's just a function with a closure that prevents the local variables from bleeding out into the global scope. That's just something to be aware of, but TypeScript also provides some tools for us to improve the tooling that we have when writing object-oriented code. For example, we can mark members as private so that they can only be used inside of this class definition. This means that we can separate our public API from internal logic for this class. For example, if we want to make this icon value immutable, we can make it private. Then we'll define a getter so the user can read the value but not change the value. Another important thing to point out here is that class instances can have their own internal state. Let's imagine we have a button where the user can toggle the emoji and maybe go back and forth between different states. This is a really simple thing to implement in object-oriented programming. We'll add another private property to this class called previous and then use a getter to retrieve that value. Then we'll define a change method, which will mutate the actual icon value on this instance. When that happens, we'll first change the previous value to the current icon and then update the current icon to the new value. On the first console log, we get the sun icon and undefined. And if we mutate the state a couple times, you can see that our internal values on this class instance have changed. So the end result is that we have a class that's encapsulated all the logic for how an emoji should work. And with TypeScript, we automatically have an interface and documentation for this class. Another cool thing you can do with classes is define static methods. The unique thing about a static method is that it's on the class itself and not an instance of a class. So we'll just go ahead and define a static method here, which itself is actually a pure function, and its job is simply to add 1 to the input argument. The cool thing is that we can now use the emoji class as a namespace to run this function. Now we're going to switch gears and talk about composition versus inheritance for code reusability. This is an area where people tend to get very strong opinions, and the actual definition of composition tends to be a little convoluted. But the whole thing really just boils down to this. With inheritance, you start with a larger base class, then have child classes inherit all of this functionality and override or extend it with whatever custom behaviors that they need. Composition, on the other hand, breaks apart the interfaces and logic into a lot of small pieces, then builds up larger functions or objects by combining these pieces together. Let's go ahead and take a look at an example of inheritance. We start with the class of human that has a public property of name and has the ability to say hi. But what if we have a lot of other objects in our program that are similar but implement slightly different features based on what they're designed to do? For example, in a video game, you might have a human character and then a superhuman character that has all of the human abilities but with a little something extra. In TypeScript, we can simply inherit all of the functionality from the human class by saying superhuman extends human. We do have an argument in the constructor, so we'll also need to add that to the constructor without private or public. Then we call super, which will execute the code in the constructor of the parent class, which in our case is just initializing this name property. At this point, we'll go ahead and define an additional method called superpower. Then we'll create an instance of the superhuman class, and what you'll see here is that it has the superpower method, whereas the regular human does not, but the superhuman can still call all the methods that were defined in the parent class. Inheritance can be great in the right situation, but you want to avoid creating really deeply nested classes because it becomes very hard to debug when things go wrong somewhere in the middle. As an alternative, we can use composition, and there are actually multiple different ways we can apply this pattern. In Angular, we can do it by injecting services into our components, and also at the template level by creating directives. I'm not going to cover that here, but it's just one of the awesome things about Angular that I've covered in many other videos. Another alternative is to concatenate objects together, which I've seen covered in several different articles on the web. The idea here is that you decouple your properties or behaviors into objects or functions that return objects. We can then merge all of these objects together into a final function that does everything that we need it to. This is usually referred to as a mixin pattern, and it's just a certain type of multiple inheritance. So the terminology between composition and inheritance is sort of convoluted. In any case, this mixin pattern can be very powerful. But in its current form, we lose all of the ergonomics of class-based object-oriented programming. That might be a good or bad thing depending on who you ask, but TypeScript actually gives us the flexibility to use mixins in a class-based format. First, I'm going to pull in this really ugly function from the TypeScript docs, which we'll see in use here in just a minute. From there, I'm going to create a couple of small behavior classes that define the individual behaviors instead of trying to encapsulate everything in a single class. So these classes are more concerned with what something does instead of what something is. Now, in the superhero class, there's a very subtle difference from the previous example. Instead of extending the class, we are going to implement multiple classes. When you implement something, you're only concerned about its interface and not its underlying code. It's the apply mixins function that we defined at the very beginning that will actually take these interfaces and apply their code to this class. That does leave us with some extra boilerplate code where we have to actually type the return values on the methods for this class. In this case, we have two methods, say hi and superpower, both of which return strings. And the final step is the requirement to call that apply mixins function with the base class as the first argument and the mixed in classes as the second argument. Now we can finally answer the question, is a hot dog a sandwich? If you use inheritance, then you're going to have to inherit from some base sandwich class, which means it is a sandwich. But if you use composition, then you can just pull in the hot dog in the bun, meaning that it is not a sandwich. I'm going to go ahead and wrap things up there. If this video helped you, please like and subscribe. And I just want to say thank you to everybody for an amazing 2018. I'm super grateful for the community around this channel, and I look forward to pushing things even further in 2019. I'm going to be taking a short break for the next couple weeks, and then I have a video planned for January 1st, so stay tuned for that. I hope everybody has an awesome end of the year, and you can still find me on Slack if you have any questions or need anything at all. Thanks for watching, and I'll talk to you soon.